day everyone. Today you are here with Fred Lunod, a third year student from University of Namibia, Ifikepunye Pohamba campus. So as I'm here with you today, we are going to touch a few things on fractions. We know fractions at large is a very challenging topic for our senior primary learners. And I have discovered some issues, some challenges they face when working with fractions. In some areas such as comparing an order of fractions and equivalent fractions. What I've discovered is that most of the learners believe that fractions with bigger denominators are greater than the fractions with smaller denominators, hence it's vice versa. Say for instance, they believe a half is smaller than a quarter, since 4 is the biggest number between 2 and 4, which is very wrong. They lack the understanding of equivalent fractions. They don't realize that fractions may be equal, hence their numbers are different. Say for instance, a half and 2 quarters can be equal, but they will still believe that they are not equal since they have different numbers. So we have come along to resolve this problem during our PBL project course. I and my colleagues, we came up with fraction as our topic to resolve this issue. So to resolve this issue, we decided to come up with a fraction wheel, a product that we have here. So before I start off on how to use this wheel, let me first give you a description on how we made this wheel. Simply, as you see, it is being made with boxes, simple boxes, as you see. Boxes. We just decided to come up with these colorful posters to cover, to attract our learners, for it to be attractive when teaching. So as we know, most of the learners don't focus with dull materials. So we come up with these posters for it to be attractive. So some accessible materials that we used are glue, this steel that you see to make the center of it, some sellotape to cover the tops of the wheels for it to last a bit longer. As you see, this box may not last longer, but we tried our best to come up with this. So for durable products, durable wheels, one can use cardboards to make this same wheel, or even hard plastics or wood for advanced crafting for it to be more durable. That's how we came up with our wheel. So let's go into more details on to check how one can use this wheel to work on fractions, on how it can be manipulative to solve these problems that we discovered. So to first start with equivalent fractions, to work out equivalent fractions. First of all, one thing I would like to say is, let's assume that all these wheels represent the same size, regardless of the original sizes they have been cut off. This one, what I refer is this one is equals to the last wheel, a 10th wheel. That's what I basically mean, regardless of their sizes. So to check on the equivalency of the fractions, let's check. Um, 1 is the whole, so 1 is equal to all the fraction sectors here on its back. So let's work on the equivalent fractions of a half. Of this half, we go in clockwise. Of this half, we go in clockwise. So let's check which fractions are equal to a half. To check on the fractions that are equal to a half, we focus on this to the line this division into the center of this whole, this division. So we check on which fractions align with these two ends. So here we have a third. It aligns with this one, but it doesn't extend here on this one. So and it extends here, which doesn't go along with this division line. So that means that half is not equal to a third. Then we move on with quarters to check. Simply as we see, this quarter aligns with this line and also aligns with this line. So it's not only 1/4 that is equals to a half. 2/4 cover to be equals to this half. So meaning a half is equals to 2/4 equivalent fractions. So if we move on with a fifth, it aligns here but doesn't align here. So meaning a fifth and a quarter are not equal. So if we move on with a sixth, it aligns here with this sixth and aligns here with this sixth. But it doesn't mean 1/6 is equals to a half. So if we run clockwise to check how many six it covers to complete a half. So basically it's 1, 2, 3, 6 that are equals to a quarter, and so forth. So that's how we use to find equivalent fractions. So to move on with comparison and order of fractions. As I mentioned earlier, most of the learners believe fractions with smaller denominators are less than smaller than fractions with greater denominators. Hence, it's very wrong in their understanding. So let's have a look at on how to compare and order fractions using this wheel. So we work in clockwise direction. So to check the difference between a half and, say for instance, a third. Yeah, let's not go far. A half and a third. Between a half and a third, which one is greater than the other? Most of the learners will say a third is greater than a half, since 3 is bigger than 2, which is very wrong. So regardless the sizes of the wheels, let's say as I uh, stated earlier, let's assume they have the same size but have different divisions. So to check on which one is greater, we focus on these division lines to check half runs from here to here. So to check on the third, does it go over a half to be greater than a half, or does it only cover a slight piece of a half to be less than a half? So simply it runs from here to here, 1/3. That means it doesn't go over a half, meaning a third is smaller than a half. So So if we check a third and a third runs from here to here, and a quarter runs from here to here. So let's check if one quarter goes over a third to be greater than a third, or it only ends in the middle of a third, or a slice in a slice piece of a third to be smaller than a third. So as we see, a quarter doesn't go over this third, meaning it's not greater. Hence, the denominator of 4 is bigger than the denominator of 3. That's how we work on comparing an order of fractions using this wheel. So one can also manipulate this wheel in such a way to remove some parts of the wheel to only focus on the fractions one is working with. So here I have removed other parts of the wheel just to focus on the 10th and the 9th of this wheel, sections of this wheel. So if we check on the comparison between a 9th and a 10th here, so this line aligns with for them to make it easier to on how to work with it. So for us to check which one is the greatest between a 10th and a 9th, Elena will simply say a 10th because 10 is bigger than 9, which is very wrong. So we check on the pieces being covered. So a 10th runs from here until here, but a 9th runs from here going over 10th until here, meaning a 9th is greater than the 10th. So there are different wheels, so it depends on which fraction unit one is working with, so it can be manipulated in such a way to make it easier to work with it. So finally, what I will recommend for our mathematics teachers is to come up with concrete teaching aids that will make it easier for our learners to understand when doing a certain problem. This doesn't only apply to fractions, but to most of the topics in mathematics, since it requires concrete models. Most of what I've discovered is most of the teachers only use theoretical methods, complex ways to teach mathematics. So that's what I will recommend for us to use something concrete. To also use real life applications when working with mathematics. So thank you.